Okay, so what if I told you there's a math problem so simple you could literally write it on a napkin, but it was so tough that it stumped the absolute greatest minds on the planet for more than 350 years? I mean, this isn't just some dry story about numbers. Nope, it's a tale of obsession, of years of secret work, and one incredible flash of genius that finally solved a riddle for the ages. Let's dive into how one of the biggest mathematical mysteries of all time was finally cracked. All right, so you probably remember the Pythagorean theorem from school, right? A squared plus b squared equals c squared. It's pretty straightforward, and there are a ton of solutions that work with whole numbers. Think 3, 4, and 5. Easy. But look what happens when you make just one tiny change. Instead of squaring the numbers, what if you raise them to any power greater than 2? So cubed, or to the power of 4, 5, whatever. All of a sudden, that simple little equation has 0 solutions. I'm not kidding. None. Not a single one using positive whole numbers. That baffling idea is Fermat's last theorem. And this is the guy who started it all. His name was Pierre de Fermat. And get this, he wasn't even a professional mathematician. He was a lawyer. So around 1637, he's just reading this ancient Greek math book, and he scribbles a little note in the margin. He says he's found a truly marvelous proof for this idea. But, and this is the legendary part, the margin was too small to write it down. Just like that, with one little tease of a sentence, he kicked off one of the longest, most epic quests in the entire history of science. So yeah, Fermat basically threw down this mathematical gauntlet. And for centuries, the world's absolute best mathematicians tried to pick it up, and every single one of them failed. And what's so wild is just how much time went by. I mean, the progress was agonizingly slow. It took more than 100 years just for someone to prove the case for n equals 3, then another 50 years to crack n equals 5. By the time we get to the mid-1800s, they'd only managed to knock out a few specific numbers. A general proof, one that worked for every single number, well, that seemed totally impossible. Okay, so let's fast forward to the 1990s. We've got this amazing new tool, right? Computers. So mathematicians basically set them loose on the problem, checking the theorem for all prime exponents up to 4 million. And you know what? It held up every single time. But, and this is the really crucial part, that's not a proof. That's just checking a ton of examples. It doesn't tell you why it's true. For all they knew, a counterexample could be hiding out there at 4,000,001. So at this point, the problem is just legendary. It's like a mathematical monster, a slayer of even the greatest minds. You wouldn't believe how many incorrect proofs were submitted over the years. Thousands of them. But the core mystery? It was completely untouched. So the breakthrough, when it finally happened, didn't come from building on any of those old attempts. Not at all. It came from a completely unexpected direction. It came from connecting Fermat's ancient little riddle to two of the most modern and complex areas of math imaginable. It was, seriously, like a link from another world. The first piece of the puzzle was something called an elliptic curve. Now, don't worry about that crazy-looking equation. That's not the important part. Just think of them as a very specific type of mathematical object that number theorists study a lot. The key thing here is, on the surface, they had absolutely nothing to do with Fermat's last theorem. And this is where the new strategy gets really, really clever. So in 1984, a mathematician named Gerhard Frey has this totally wild idea. He figures, okay, let's pretend a solution to Fermat's theorem exists. If it did, he realized you could use those numbers to build a really, really strange hypothetical elliptic curve. This Frey curve, as it's called, would be a total mathematical freak. It would have properties so bizarre that it just shouldn't be able to exist if another big idea called the Taniyama-Shimomura conjecture was true. And just like that, the whole game changed. Forget trying to prove Fermat directly, the new goal was to prove the Taniyama-Shimomura conjecture. So there it was, a new path forward. Now at the time, almost no one thought the Taniyama-Shimomura conjecture was actually provable. It was seen as just too hard. But for one mathematician, this wasn't a roadblock. It was the opportunity he'd been waiting for his entire life. And that mathematician's name was Andrew Wiles. See, he had been obsessed with solving Fermat's lost theorem since he was just a kid. It was his childhood dream. So when he heard about this new, unexpected link, he knew this was it. This was his chance. And so for the next 7 years, he went into his attic and worked in total secrecy. He told absolutely no one what he was up to, except for his wife. So in 1993, Wiles emerges. He's ready. He gives a series of lectures and announces his proof to the world. And the news was absolutely electric. The math world went wild. But then, during the intense peer review process, as other mathematicians checked his work line by line, they found a flaw. It was tiny, but it was critical, and it was buried deep inside his logic. After 7 years of secret obsession, the proof was broken. What happened next is one of the most dramatic, most human stories in all of modern math. For an entire year, Wiles tried everything to fix the error, and he was failing. He was right on the verge of admitting defeat, and then it happened. On the morning of September 19th, 1994, he had this moment of pure, sudden inspiration, an incredible revelation. He realized that the very thing that was making his new method fail was the exact key he needed to make one of his old, abandoned approaches work. It all just clicked into place. As he later said, it was so simple and elegant, he couldn't believe he'd missed it. It fixed everything. So in May of 1995, it became official. 2 papers were published in the prestigious Annals of Mathematics, the main one by Wiles, and a shorter one co-authored with his former student Richard Taylor, who'd helped him nail down that final, crucial step. After 358 long years, the mystery was solved. But here's the thing. Wiles' achievement was so much bigger than just solving some old riddle. Remember that Taniyama-Shimura conjectured he had to prove? Well, he did it. It's now called the modularity theorem. He had essentially built a massive bridge connecting 2 once separate continents of mathematics. In doing so, he kicked off a whole new era of discovery in number theory. And so that little note in the margin was finally answered. Maybe not with the simple little proof Fermat thought he had, but with something so much grander, a stunning masterpiece of modern mathematics that literally reshaped the entire field. You know, the story of Fermat's last theorem is just such a powerful reminder that some problems, they take generations to solve. They require totally new ideas and completely new ways of thinking. And it leaves you with this one really inspiring question. What impossible-seeming problem, right now, today, is just waiting for its own Andrew Wiles to come along and solve it?